TCP uses a sliding window to handle flow control. The sliding window protocol used by TCP, however, is something between go back and selective repeat sliding window. The sliding window protocol in TCP looks like go back and protocol because it does not use NAK, negative acknowledgements. The sliding window will have the window size, starting window and closing window. The difference will be the window size, and the sliding window can move to the left side and right side. Sliding window is used to make transmission more efficient as well as to control the flow of data. TCP sliding windows are byte oriented. Some important points about TCP sliding windows. The size of the window is lesser than RWND and CWND. The source does not have to send full windows worth of data. The window can be opened or closed by the receiver but should not be shrink. The destination can send an acknowledgement at any time as long as it does not result in a shrinking window. The receiver can temporarily shut down the window. The sender, however, can always send a segment of 1 byte after the window is shut down. TCP is a reliable transport layer protocol. This means that an application program that delivers a stream of data to TCP relies on TCP to deliver the entire stream to the entire application program on the other end in order without error and without any part loss or duplicated. For that, the TCP provides reliability using error control. Error control includes mechanisms for detecting corrupted segments, lost segments, out of order segments, and duplicated segments. Error control also includes a mechanism for correcting errors after they are detected. Error detection and correction in TCP is achieved through the use of three simple tools: checksum, acknowledgement, and timeout. This is one example for normal operation. The client sends the sequence number 1201 to 1400 with acknowledgement number 4001. That means it is expecting the data with sequence number 4001 from server. Now the server is sending the sequence numbers from 4001 to 5000 with acknowledgement number 1401. That means it have received up to 1400. It is waiting for 1401. Now the client is giving the acknowledgement 5001, which means that the client have received the sequence number up to 5000 and it is waiting for the sequence starting from 5001. The server is sending 5001 to 6000 sequence with the same acknowledgement 1401. That means it is waiting for the sequence starting from 1401 and it is sending the data starting from 6001 to 7000 without waiting for the acknowledgement, and the client is giving the acknowledgement 7001, which means that it have received up to 7000 and it is waiting for the sequence number 7001. Now previously we have seen the normal operation. Now we will see one example. If a segment is lost during transmission, what will happen? In this example, the sender is sending the sequence number 501 to 600 and the sender is sending 601 to 700 without waiting for acknowledgement. The receiver is giving the acknowledgement number 701, which means that it have received up to the sequence number 700 and it is waiting for the sequence number 701. Now the sender is sending 701 to 800. Let us assume this segment 701 to 800 is lost during the transmission. But the sender do not know that that particular sequence is lost. So without knowing this, the sender is sending 8012 to 900 sequence number. But the receiver is waiting for the sequence number 701 to 800, but it is lost already. But it is receiving 8012 to 900. So the receiver is giving the acknowledgement as 701 to inform the sender it is actually waiting for the sequence number 701. So the sender comes to the conclusion the sequence 701 to 800 is not received by the receiver. So it is resending the sequence 701 to 800. After receiving it, the receiver already have received 801 to 900. So it is giving the acknowledgement 901, which means that the receiver have received up to sequence 900 and it is waiting for 901. So this example explains the particular example of the sequence number 701 to 800 is lost during transmission and it is retransmitted once again by the sender. The receiver TCP delivers only ordered data to the process. Fast retransmission. Another example, the sender is sending the sequence number 101 to 200, then it is sending 201 to 300. The receiver is giving the acknowledgement 301, which means that it have received up to the sequence number 300. The receiver is waiting for the sequence number 301. Let us assume the sequence 301 to 400 is lost during the transmission. But without knowing this, the sender is sending 401 to 500, but the receiver is giving the acknowledgement for 301. That means the receiver have not received the sequence 301 to 400, it is waiting for it. But before getting it, the sender is sending 501 to 600. Again the receiver is sending the acknowledgement 301, it is waiting for 301 to 400. Before getting it, the sender is sending 601 to 700 also. Again the receiver is sending acknowledgement 301. So 3 acknowledgements are given for 301. So it is retransmitting 301 to 400. So in this way it is using the transmission in a faster way.